Radical operations, day 2 notes. The Ed puzzle said that you can add and subtract radicals if the radicand is the same number. Just add and subtract the coefficients. So since this radical 5 and this radical 5 are the same, you just do 7 minus 3, and the radical 5 comes along for the ride. Again, they likened it to if you have 7x minus 3x, since you have like terms, then that is just 7 minus 3 is 4x. So that's how it is similar. The next one, you have a radical 3 here, radical 3 here, radical 3 here. All have the same radicals, so you just add those. So that's 15 minus 10 is 5, radical 3. The next one has multiple radicals. It's got a radical 5 and a radical 5. So that's 4 and a minus 1. So if there's no numeric value out there, the coefficient is a 1. Just like if you have an x, it's a 1x. So 4 radical 5 minus 1 radical 5 is 3 radical 5. Then you have a radical 2 and a radical 2, so you just take 7 minus 8 is negative 1 radical 2. The negative doesn't always have to be there. If you see it written like this, that's the same thing. But the rule number 1 is always to make sure that your radicals are simplified in the first place. So 2 is as simplified as it can get, but 12 and 18 can simplify. If you remember from the last section, 18, breaking it down into its prime factorization is 2 times 3 times 3. 12, breaking that down into its prime factorization is 2 times 2 times 3. And that is as simple as it can get. So I circle any pairs, bring them out. There was already a 3 out there. So 3 times that 3, the radical 2, since it doesn't have a partner, stays home. This is 9 radical 2. This one becomes 3, pair of 2's comes out as a single 2. He stays home, so that is 6 radical 3. This nothing can happen, so it's just 2 radical 2. Oops. Plus goes here, plus goes there. This is just 2 times radical 2. This radical 2 and this radical 2 are the ones that are the same, so 9 plus 2 is 11 radical 2, and that guy doesn't have anyone to add to, so you just bring him down. Next one, same thing. Simplify the 20, simplify the 20, simplify the 45, simplify the 125, and see if you can have any like radicals. Put it on pause and try this problem by yourself, and then press play to see how you did. So I simplified, or I broke it down into its prime factorizations. This first one becomes 2 times 2 radical 5, this 2 and that 2, 4 radical 5. This one becomes 2 radical 5. Pair of 2's comes out as a single, and the other 5 stays under. This one simplifies. There's a 2, and the 3 comes out, radical 5, and this one simplifies to 6 times 5 radical 5. So that's a minus 2 radical 5. That was a minus 6 radical 5. This is a plus 30 radical 5. They all have a radical 5, so I can add all of them together. 4 minus 2 is 2. 2 minus 6 is negative 4. Negative 4 plus 30 is 26. And the radical 5 comes along for the ride. The next section, which is new, is distributing or multiplication. And we learned this last section. If I had this times a binomial, I can distribute it to both. So this first one becomes 2 radical 5 times radical 6 plus 2 times 2, since those are both out, and the radical 5 doesn't multiply to anything. So this is 2 radical 30 plus 4 radical 5. Underneath gets multiplied underneath. Things that are out get multiplied out. Now does 30 simplify? That's 3 times 2 times 5. There's no pairs. These are not like terms, so I cannot do anything else. That is my final answer. Another example, distributing. So when I'm multiplying this to this first term, I have no number outside, but I do have a negative 5, so he's outside. I have a radical 3 and a radical 10, that's a radical 30. Then when I multiply to the second one right here, that's plus. Radical 3 is underneath, radical 6 is underneath, so since they are both radicals, I can multiply them underneath. It's 18. 30 we said did not simplify, but 18 does. Remember, you always have to simplify the radicals. And 18 was 3 times 3 times 2, so that comes 3 radical 2. And the 30 doesn't simplify. That was 3 times 2 times 5. There's no partners. This one did have a partner, so he simplified. There were no pairs underneath here, so this is as simplified as you can get. The next problem, I have a binomial now times a binomial. So instead of just a single distribution, 1, 2 multiplications, now I'm going to have 1, 2, 3, 4 multiplications. So radical 5 times radical 5, that's radical 25. Radical 5 times radical 3 plus radical 15. Then I take the second one and I multiply them. Radical 3 times radical 5, there's a minus, so it's radical 15. And radical 3 times radical 3, there was a minus, so it's minus square root of 9. So if they're all underneath, they get multiplied underneath. Radical times a radical, multiply underneath. Radical times a radical, multiply underneath. Radical times a radical, multiply underneath. Now I do notice that 25 and 9 are both perfect squares. So the square of 25 is 5. These do not simplify. 15 is 5 times 3, no pairs. The square root of 9 is 3, so it comes out as 3, no more radical left. Now these are just regular old numbers that you can add together. 5 minus 3 is 2. And this is a positive radical 15, and this is a negative radical 15. So if I have a positive 1 and a negative 1, those actually cancel out, and 2 is your final answer. Here's an example where they do not cancel out, but since you have a squared, remember to write it twice. And I have 2 values times 2 values. A binomial times a binomial, there's going to be 4 multiplications. We'll start with this one and this one. So radical 7 times radical 7 is radical 49. Radical 7 times 3, 3 is on the outside, 7 is underneath, so you write 3 on the outside and 7 underneath. 3 gets multiplied to the radical 7, 3 is out, 7 is under, 3 is out, 7 is under. And then the last one is just 3 times 3, which is 9. This one right here is a perfect square. 49, square root of 49 is just 7, plus 3 radical 7, plus 3 radical 7, plus 9. The 7 and the 9 add together to give you 16. And the 3 radical 7 and 3 radical 7 are like radicals. So I just do 3 plus 3, which is 6, and the 7 comes along for the ride.